let's examine some of these exercises that we have for this notebook. So the first one says, encapsulate the entire process of gathering the corpus, constructing and training a model into a function. Afterwards, deploy the model to other sets of hominins. So notice we did things a bit piecewise. We had a function that gathered the corpus, we went and constructed their labels, but it'd be nice if we can encapsulate that into a function. And let's consider what we want this function to do. We want this function, we want to pass to this function things like, what are the hominins we're trying to classify? In other words, in this example we saw, we have Python the animal and Python the programming language. It can take those, it can look for the respective pages on Wikipedia, gather the corpus, process it, train the machine learning model, and return to us a fitted model. So I have a very nice interface where you can go ahead and say return, we say get classifier, and we can pass, let's say, something like Python, maybe animal, and language, and from there it knows what to do. So let's start working on this. So let's go back to see how we gathered our corpus. So we did this outside of a function. So we got the animal sentences, the language sentences, and we combined it. Let's do this all. Let's see if we can do this all in one step in one function. So what other homonyms should we go ahead and use and investigate? In other words, we looked at Python the programming language and Python the animal. Is there something else we should go ahead and use? Perhaps something that's interesting. One that I thought about is, how about Amazon? When I said Amazon, what was your first thought? Did you think of the rainforest, or did you think of the company? Or maybe perhaps you thought of the Amazons in Greek mythology. So yeah, in this situation, if we use the word Amazon, there could be multiple things we're referring to. The company, the rainforest, or the race of women in Greek mythology. So in that situation, we no longer have a binary classification. We have a multi-class, 3 classes here. Alright, so I'm going to go ahead and create a function called getCorpus that will do this automatically for me. So define a function called getCorpus. I'm going to pass it a variable called words. So let's consider what we need to get our corpus. So we're going to rely on the Wikipedia Python package to easily get those articles. And when we use that package, so that capability to fetch to get the pages, we need to pass a string referring to the page. So let's go to Wikipedia and see what happens if I type in Amazon. So Amazon usually refers to, looks as it forest things. So there's actually Amazon the river, which is closely tied to the rainforest, so we'll just ignore that. So mostly either the mythical tribe of women, the rainforest, or the company. So let's go ahead and open up these pages so we know how they're called. So we look at it here, and this one's just called Amazons. This one's called Amazon underscore rainforest, and Amazon underscore in parentheses company. Okay. So what we can go ahead and do is let's create a dictionary. I'm going to call this dictionary words. This dictionary is going to have, let's say, Greek. So this is the label we're going to use for the articles for, let's say, Amazons. So Amazons. And let's say rainforest. We're going to use define a label called rainforest, which is going to refer to Amazon, the rainforest. So right here in brackets in the list, the value for the key is going to refer to the page, and where I'm getting this string is based upon this last part. So beyond wiki, this is of interest. This is what I want to go ahead and use. This is what I'm going to refer to this page. This is what the package needs. And the reason why I am putting this string in a list is what we saw before. Sometimes we want to go ahead and use multiple pages to construct the documents for that class. Remember, we understood that with Python the animal, those documents, that page wasn't very long, so we used 2 pages. We used ball Python, I believe, and reticulated Python, 2 different Wikipedia pages, articles, to construct all the documents for that class. This example here, we just only have 1 page for each class. We have that flexibility. And the last one, I'm going to call that label company. Notice these labels are arbitrary, just what I want to use. And then the value is, in this case, what was it called? Amazon underscore company in parentheses. So make sure I write that out exactly. Okay. There you go. In fact, we can go ahead and try this out. Remember, there was a page. Let's look at the documentation here. Yeah, so get a Wikipedia object for the page title. Okay, that should work out. Yeah, so that's what I wanted. So let's say Amazons. And there's the Wikipedia page for Amazons. Okay. Let's flesh out this function here. So what I want to do is let's go ahead and define 2 lists. One list of the corpus, empty list there, and the one are the labels for all the documents in our corpus. And what I want to do is I'm going to iterate through all this. I'm going to iterate through this dictionary that we would pass to the function. So for key and value in words.items, we can go ahead and say get the docs. So we're going to use that page to sentence function that we defined up above. Remember how this function worked? We did pass the page. Sorry, the string referring to the page. It got the page and went and parsed it and pulled out all the sentences in that page. Since v, the value of the dictionary, is going to be a list or an iterable, I'm going to unpack all the items in that list. So use the unpacking there. Let's add to the corpus. So every time we go through this for loop, we'll add to the corpus by adding the docs. And the labels will be this key, this arbitrary key we defined, times the size of the docs. So this will construct a label for all our observations. Okay, and then after we run that, we want to make sure we return the corpus and the labels. All right, let's go ahead and try this out. Let's go ahead and define this function here in this cell, and let's get our corpus. Might take a while because that's to gather all the resources. Okay. Perhaps it was better if I just unpack the result, corpus and labels. Take the length of corpus. See how many documents we have retrieved. Okay, so 800 documents. Let's take a look example of some of those documents. Let's say give me sentence 50, so it's just mythology. That's not very helpful there. Okay, later he says establish a little way beyond. Okay, so this is referring to Amazons, the tribe of women. Let's look at -20. Civil rights group concern lead to expansion of surveillance and prone to abuse. So this is referring to Amazon, the company. Okay, so that worked out. And if I look at the length of, if I look at my labels, it's company or, let's see, yeah, let's make sure that makes sense. They're all company for some reason. And the reason why is because if I messed up here in the function, I forgot to augment. So there we go. Run it again. So the last document should be for the company, and the first set of them should be for for Greek mythology. There you go. So that worked out. So you can see this will be the first step in trying to encapsulate the entire process. So you can have something just say, get my classifier. We can pass something like this. Go ahead and do all this nicely for us automatically, return to us our classifier. We'll go into the rest we do there, but it's pretty straightforward. Let's go and focus on the next question here. So the next question says, measure the model's improvements by stripping out things such as the use of stopwords, lemmatization. Perhaps you can incorporate model additions, parameters to previously mentioned functions. What model additions increases the performance the most? So so this whole thing is we want to consider, how much does stopwords, including stopwords, help out? How much does including lemmatization helps out? So let's go ahead and consider this next.